remove and refit headlamp and other lamp assembly. Objectives: renew headlamp bulbs, other bulbs, remove and refit headlight assembly, removal and installation of heel lamps, turn signal lamp. Disconnect the headlamp connector. Installation is the reverse of removal. Caution: do not touch the surface of the bulb with hands or dirty gloves. Rear combination lamp. Disconnect the battery negative terminal and loosen the rear combination lamp mounting screws. Disconnect the combination lamp connector. Installation is the reverse of removal. Purpose of clutch, gearbox and differential. Objectives: to know the purpose of the clutch unit, the purpose of a gearbox, the purpose of a differential unit, the concept of a trans-axle, the integrated layout of the clutch, gearbox and differential, and to identify the basic components of the clutch, gearbox and differential. The clutch. Transmission clutch performs two tasks. It disengages the engine from the transmission to allow gear changing. It is a means for gradually engaging the engine to the driving wheels. When a vehicle is to be moved from rest, the clutch must engage a stationary gearbox shaft with the engine. This must be rotating at a high speed to provide sufficient power, otherwise the load will be too great and the engine will stall or come to rest. The clutch used depends on the type of gearbox. Automatic gearboxes normally use a fluid clutch which automatically disengages when the engine speed falls below 800 revolutions per minute. Manually operated gearboxes use a dry friction clutch. Friction clutches. A friction plate sandwiched between the engine flywheel and a spring-loaded pressure plate transmits the drive to the gearbox. The extent of the drive is controlled by the force which is clamping the plate. Lowering the driver pedal causes disengagement by separating the friction surfaces. During this operation, the force of the spring is taken by the driver. Initial upward movement of the pedal causes the friction surfaces to contact. Further pedal movement allows the full spring force to act on the driven plate to ensure that all plates rotate at the same speed without any slip. Types of friction clutches. Most friction clutches are of the dry type. That is, they do not run in oil. The clutch will not function effectively if oil gets on the asbestos-based friction lining. Most vehicles use a single plate type because this compact design is efficient, especially as regards to the disengagement. Pressure on the friction plate is obtained by using diaphragm multi-spring assembly. Cars commonly use diaphragm-type clutches. The failure of surface to grip resulting in the driven plate revolver slower than the engine flywheel. In such a case, clutch gets hot and emits an odor. The gearbox. Besides providing forward or reverse motion of a vehicle, the gearbox must overcome one of the drawbacks of the internal combustion engine, that is the poor torque output at low engine speeds. Gearing is provided either to 1. Boost the engine torque, or 2. Enable the engine to be operated at speed where its output power is high. Synchromesh. As the name suggests, this type of gear has a synchronization device which equalizes the seeds of the two members that have to be meshed to obtain the gear. The Synchromesh gearbox gives a simpler, quieter and quicker gear change. Propeller shafts and universal joints. The propeller shaft transmits the drive from the gearbox main shaft to the final drive pinion. The shaft is long and tubular and balanced to reduce vibration. A shaft connecting the final drive to an independently sprung driving road wheel is called a drive shaft. Universal joints. A universal joint is a device to transmit the drive through a varying angle. Axle movement due to bumps in the road cause the distance between the gearbox and the rear axle to alter. A universal joint allows the movement at the sliding flexible joint. Final drive and differential. A conventional transmission has a tubular rear axle to support the weight of the rear of the car. This axle contains the final drive gears, differential and axle shafts. The final drive gear brings down the speed to suit the road wheels and redirects the line of drive. When a vehicle is cornered, the inner wheel moves through a shorter distance than the outer wheel. This means that the inner wheel must slow down and the outer wheel must speed up. During this movement, it is desirable that each driving wheel maintains its driving. This task is performed by a differential.